All right, what is up, everybody? We're on to week number 2, digital lesson number 3 of your virtual lessons. Today, we'll be kind of taking yesterday's lesson one little baby step farther using surface area. But as always, before we get started, go ahead, do your warm-up either on a separate sheet of paper, or if you printed out the warm-up, up to you, however you want to do that. Again, it should take you about 8 minutes. Numbers 1, 2, and 3, like all week, no calculator. Number 4, more than welcome. If you have any questions about any of these, review prior days warm-ups. Exact same types of problems, just different numbers and different scenarios. So again, pause the video at this time. When you're ready, unpause the video, and I'll be here ready for you. All right, here we go. Warm up. Question number 1. We are combining some like terms. So again, use some kind of strategy to figure out what goes together. I have a negative 5a that's being combined with a negative 6a. Again, bunch of different ways I could do this. I could draw out 5 negatives and then draw out 6 negatives. And then realize I have no zeroed pairs, so there must all be negative. That means I have negative 11a. Same sign, add and keep. 5 plus 6 is 11. I'm keeping the negative, negative 11. I'm also going to go through and eliminate b and d at this point, just so I don't accidentally click on them or circle them as my answers, because again, I know I have negative 11a, they have positive 11a. In the middle, I have a positive 6b minus 12b. Now I have different signs. So again, I could list out 6 positives, 12 negatives. And then I do have some zeroed pairs. These would all cancel out and go away. I would be left with 6 negative b's. Again, I look which answer choice. Answer choice A has the equivalent of what I wrote, negative 11a minus 6b. Again, different signs, subtract. 12 minus 6 is 6. More negatives. I kept the negative. Same signs, add and keep. 5 and 6 makes 11. I keep the negative. Question number 2. Okay. Ashley will roll a fair number cube labeled 1 through 6. I wrote out my fair number cube labeled 1 through 6. She wants to roll, or the probability she gets a number greater than 4. 5 and 6, 2 numbers out of a total of 6 are greater than 4. Well, I have to think to myself, I'm not going to choose a trap answer like 1, 6 because I know it's 2, 6. So I have to think to myself, does 2, 6 reduce? 2, 6 in a calculator reduces to 1/3. Answer choice B, 1/3 is the probability of getting a number greater than 4. Number 3, temperature outside started at positive 2 degrees. It dropped, went down 2 degrees every hour for 8 hours. Again, it started at 2 degrees. It went down 2 degrees, so in 1 hour, it's 0. In 2 hours, it went down -2. In 3 hours, it went down another 2, -4. In hour number 4, it went down 2 hours. Hour number 5, 2 degrees. Hour number 6, another 2 degrees, it went down. Hour number 7, another 2 degrees. Hour number 8, it ended at -14 degrees. If you're doing these problems a different way and your strategy's been working all week, there is more than one way to do these problems, and it will work as long as you are doing it without a calculator. Number 4, again, I added up all the numbers without a fancy calculator or scientific calculator that has a mean program built into it. I have to add the numbers to get the sum. I listed the number of data points, 1, 2, 3, 4, 5, 6, 7, 8. 4,960 divided by 8 means that the mean was about 620. So today, as I said, we're going to be doing a little bit more work with surface area, but we're actually going to use the surface area to answer a problem or a word problem. So up here, take about the next 2 or 3 minutes. The first thing I would do is I wouldn't worry about what's written below here. Okay? I would solve this surface area. I would think I have a rectangular prism. It's made up of 6 boxes. I would draw out your 6 boxes, left, right, top, bottom, front, back, and I would solve this just like you did yesterday. Take about 4 or 5 minutes to work this out. When you're done, this is the work of someone who would have gotten this problem wrong. Think about what they did wrong, why their answer's wrong, and what you could have done to fix it. Pause the video at this time. When you're ready, I'll be here. All right, here we go with it. First up, I think to myself, well, let's figure out what information. I know I told you to solve it, and maybe you already have an idea of what this student did wrong, but I'm going to kind of reverse engineer this and go with the information they did and then kind of find the mistake and add to it or fix whatever mistakes they did do. So I see that he listed 4 boxes. Well, let me think about what sides he actually listed here. 11 by 5. Well, the bottom here is 11 by 5. And the top doesn't have any values, but I know that the top and the bottom in a rectangular prism are the same. So let's see. top and bottom, 11 by 5, 55. They're both right, so I'm going to say that these two numbers are okay. So that's not where the mistake of this student lies. Let me erase what I have. Okay, 5 by 6. Well, let me trace. I see a 5 and a 6 over here. Let me trace the bottom, the side here. It looks like they found the right side. Okay, well, I know that the right and the left in a rectangular prism are the same. So 5 times 6, they're both 30. Well, top, bottom, left, right, but there's 6 sides. So that means they forgot the front and the back. So this student didn't realize that there's 6 sides to a rectangular prism, almost like a shoebox. And they have a front and a back, along with a top and a bottom, along with a right side and a left side. So let me erase my side here. Let me take my red pen here and let me trace the front or the back. Well, let me trace the front. Looks like there's some numbers easily found here. 11, okay, doesn't tell me anything, doesn't tell me anything, doesn't tell me anything. Okay, well, I know that the front and the back are both going to have dimensions of 11 with something else. Let me trace the back, because again, if I didn't find it here, it must be on the other side. Well, I trace nothing, nothing. Oh, there's something, 6. Okay, so I know that the other missing dimension, the width, must be 6. So again, 11 times 6, 66. Well, they already added these 4, so I know 170 plus 66 plus another 66. Again, let me grab my calculator. 170, the area of the 4 sides they found, plus 66 means that the real answer should have been a surface area of 302 square inches. Okay, really important because again, as you can see, trap answers are going to be all over the place on the real test quiz or EOGs. All right, up here. Okay, if you feel comfortable with finding surface area, again, you can pause the video, do all the work. Again, break it apart. We have a triangular prism. Well, I think to myself, I know I have 2 triangles. I have a front and a back triangle. Each triangle, if I trace them, has a side that turns into a rectangle. I have a left side, I have a right side, and I have the bottom that it's sitting on. So I have a left side, a right side, and the bottom it's sitting on. After that, again, I got to think to myself, what formulas do I need? Well, I know that if I have triangles, I'm going to need the area formula of a triangle, 1/2 base times height, or again, base times height divided by 2. And if I have a rectangle or square, I'm going to need length times width. Notice, I have not done any math yet. All I've done was taken this triangular prism, broken it apart, listed my formulas, and now I would go through and actually trace. To save a little bit of time on this one, I've already broken it apart. So again, this was the prism they gave us. This is what its 6th grade net would look like, in case you were curious. But down the bottom here, okay, I broke it apart. So again, my sides, the 2 triangles, I had to do 1/2, the sides, the rectangles here, it's a little tough to see in purple, but I'll highlight them, were exactly the same. Length times width, they were both rectangles. 11 by 9, 99. The bottom, also a rectangle. So again, I used my formula, length times width. The bottom was a 9 by 11, or again, 99. Okay, my triangles, I know they were triangles, so 1/2 base times height. Here's my right angle. I know that I have a base of 9 and a height of 7.8. Again, these 9s on the sides of the triangle help me with the rectangles. But again, I need a base and a height for my triangles. 1/2 times 7.8 times 9 is 35.1. I have all 5 dimensions. I have my left side, my right side. I have my bottom. I have my front. I have my back. Last step was to add them together. So again, this was just a review of yesterday's lesson. Now, some questions ask us to find the surface area, square centimeters. Okay, 367.2 square centimeters. And sometimes they ask us to take it a little bit further than that. Today, we'll be taking it a little bit further. So, here's an EOG word problem using the same prism we just solved for. So, a store is gift wrapping the present from the previous slide. If the wrapping paper costs 6 cents per inch, how much will it cost to wrap the entire present? Well, nowhere did it say the word surface area, but right here, they're talking about inches. and it should be per square inch, okay? Well, I already know my square inches for the entire figure, 367.2. I broke it apart, left side, right side, bottom, front, back triangles, and I figured out the total surface area. I need to figure out for every piece of this, it costs 6 inches. So 1 square inch, 6 cents, 2 square inches, 12 cents, 3 square inches, 18 cents, 4 square inches, 24 cents. Every square inch, it's costing 6 cents. So the last step is actually pretty easy if you were able to do the hard part. The hard part would be finding the surface area, multiplying it by the price per square inch, and finding out that it was approximately $22.03 to wrap this gift, okay? So again, nothing difficult. The hardest part is figuring out, is this an area or a volume problem? Well, this is pretty easy for now because we haven't touched volume yet, but per square inch lets me know this is a surface area problem. Again, I broke it apart, found my surface area, multiply it times the price in the problem, $22.03 total price. Okay? All right, another problem solving. The figure below is a step that a builder is installing. If only the top and the front are getting painted, how many square inches will be needed? Okay, a couple things. They made a big deal of this. They're only painting the top and the front. So I know that I look at this, that's 2 rectangles. So I'm going to draw myself 2 rectangles. I know they're only painting those 2 sides. How do I know what kind of problem this is? Well, it says square inches. So boom, right there, I know I have 2 squares or rectangles, length times width. Now, I know that they're only painting the top and the front. So again, all I've done so far is broken this problem apart. What information did they give me? What do I need to solve it? And now I can get into how do I actually solve. So let's start with the top. If I trace the top, well, I go by 3, but that's the only dimension I go by. But remember, the top in a rectangular prism is the same as the bottom. So I know that the top's going to be 3 times something. Let me trace the bottom. Even though they didn't ask me to paint the bottom, I still know that the bottom dimension is 18 by 3. So boom, right there, 18 times 3, that is the length and the width of the top of this rectangular step. Next up, I need to figure out what is the front going to be painted. Okay, so again, I trace the front. Well, the front was pretty easy. It looks like I go by 6 and 18. So 6 times 18. Okay, now once I have my length and my width for both the top and the front done, I pick up my calculator. 3 times 18 gives me 54 square inches. 6 times 18 gives me 108 square inches. Once I have my 2 sides that they asked me for, how many total square inches there would be? Well, that would be 162 square inches. So again, the hardest part of this problem actually wasn't the math. It was reading carefully, thinking about what parts of the problem were they talking about, what information did they give me, how can I break it down to make the math rather easy. Now, follow-up question. If the builder has 6 steps, so again, there's 6 steps leading up to this front door, and I know the surface area of 1 step is 162 inches, how can I figure out 6 of these? Well, I know that 1 is 162, another one's going to be 162, the 3rd step's going to be 162, the 4th, 5th, and 6th step are all going to be 162. Remember, repeated addition is nothing more than multiplication. So 162 times 6 gives me a grand total that 6 steps would have 972 square inches to be painted. So again, once you can find one of something, you can find any number of something, even a fraction. Maybe they only wanted to paint half the step, or a third of the step, or a fourth of the step. Once we know one, we can find anything. Okay, one more, let's try. If each ledge length, okay, so each part of this is doubled, what would the surface area of the polygon be? Okay, we can't just find the surface area of the original figure and double it. That wouldn't work. So the first thing I need to do is actually figure out what are the dimensions if they're doubled. Well, doubled, that means times 2. 3 times 2 is going to make this guy 6 inches. 7 times 2 is going to make this guy 14 inches. And 16 times 2 is going to make this guy 32 inches. Once I have that piece of information, now I can go through and actually start breaking this picture apart. Okay, so again, we're not going to find the original surface area and double it. We're going to make the new thing just like we do in a lot of scale factor problems. Then we're going to find each new piece and we can combine it at the end. Again, at this point, you should kind of have a good idea of what you're doing. I'm dealing only with rectangles, it looks like, so I know length times width will apply. I have 6 sides. I have a front, I have a back, I have a top, I have a bottom, I have a left side, and I also have my right side, okay? Once I've broken it apart, written down the formulas I need, let's start tracing. Well, I'm gonna start with the front. If I trace the front, it is now 32 by, well, there's nothing here, there's nothing here. Let me look at the back, nothing there, right here, 6. So again, 32 times 6, 32 is the length. 6 I found in the back. I know the front and the back are both going to be 32 times 6 because they're congruent, they're opposites. Okay, let me erase these red marks just to make it a little easier for us to see at home. Again, I'm going to do the top. Well, there's no dimensions on the top, so I'm going to trace the bottom. Nothing. Okay, 32 inches, 14 inches. I have my length and my width, 32 times 14. The bottom is the same as the top, 32 times 14. Almost there, just have my left side and my right side to go. Again, let me erase it for those of you watching at home. Again, I'm gonna cross to the left side, has nothing printed there. So again, I look at the right side, 14 by, there it is, 6. 14 times 6, and again, I know opposites in math are congruent. 32 times 6 means that this guy is 192, the front, that means the back is 192. 32 times 14, 448 is the top and the bottom. Left side and right side are both 14 times 6 or 84. Last step, I find all my individual areas, I add them together, 192 plus 192 plus 448 plus 448 plus 84. Let me do this real quick in a calculator, 448, 448. Would mean that this would have a total of 1,448 square inches after we doubled each side and then found the surface area. This is about as hard or as far as we take it in 7th grade. We have now completed almost all the surface area. Hopefully you've gone through these, kind of felt comfortable. The next couple of things that you'll be doing over the course of this week is a lot of just practice on this. Again, practice is going to make this a lot easier, but you have to take the time, break the shapes apart, list the formulas you need, trace the dimensions you need for each individual piece. If they're opposites, they're congruent. You can kind of skip some things like the front and the back we know are the same in rectangular prisms. Use the information that you've gotten over these last couple of days, okay? The bit.ly is up here. It's also on my website, bit.ly, capital S-A-S, solving, surface area solving. It's only 7 questions, okay? When you get into it, break each prism apart, show your work for each piece. If you have any questions, email us down below. This will be a normal problematic bit.ly, so it will either tell you your score or it will be posted either later tonight or the very next morning. Again, any questions with this stuff, please make sure you're emailing your teacher, staying current. Good job on day number 3.